Most people imagine the same thing: a vast, silent emptiness, an ocean of shifting golden sand stretching in every direction, broken only by the occasional bleached rock or a half-buried shrub struggling to survive. The air is dry and brutal, the sun is merciless, and life, real, thriving, abundant life, feels like a distant, almost laughable idea. That image isn't wrong. Deserts are genuinely among the most unforgiving environments on the surface of this planet. They are places where the soil is too dry to hold roots, where the wind tears apart anything that dares to grow, and where human beings have historically gone not to build, but to survive. And yet, in the Dalad Banner Desert, nestled deep inside the Inner Mongolia Autonomous Region of northern China, something happened that most environmental scientists would have once called impossible. Sand dunes that had been slowly swallowing farmland and villages for decades began to retreat. Bare, cracked earth started to breathe again, covered first in patches of pale green, then in stretches of dense, living vegetation. And right in the middle of this transformation, rabbits. Not metaphorical rabbits, not robotic rabbits. Real, breathing, fast reproducing, soil-turning, seed-spreading rabbits, 1.2 million of them, raised deliberately in the heart of one of China's most threatened desert landscapes. This is not a fairy tale. This is not science fiction. This is a story about how one country looked at one of its most stubborn environmental crises and decided to solve it not just with trees and drones and government decrees, but with a carefully chosen animal, a deep understanding of ecology, and a very deliberate fusion of environmental protection and economic ambition. This is the story of how China turned a desert into an oasis, one rabbit at a time. I'm Mike, and you're watching HEMS Reports. Let's get into it. To understand why what happened in Inner Mongolia matters so much, you first need to understand just how serious China's desertification problem became, and how long it took the country to truly reckon with it. Desertification is not a dramatic event. It doesn't happen overnight the way a flood or an earthquake does. It is slow, creeping, patient. It happens when the thin layer of topsoil that sustains plant life is stripped away by drought, by overgrazing, by the clearing of trees, or simply by the relentless grinding pressure of wind over decades. Once that topsoil is gone, the land beneath it is exposed to the elements, and what follows is a gradual, almost invisible catastrophe. For China, that catastrophe became very visible indeed. According to global desertification data compiled during the 1990s, China's total desertified land area had grown to an extraordinary 1.714 million square kilometers. To put that number in perspective, that is roughly the combined land area of France, Germany, Spain, and the United Kingdom. All of it turning to sand. All of it losing its ability to support agriculture, communities, or biodiversity. And that number represented nearly 1/5 of China's entire national land area. But the crisis didn't stop there. As the country entered the 21st century, desertification continued to accelerate. The affected land was expanding at an alarming rate of approximately 10,400 square kilometers every single year. That's roughly the size of a mid-sized city being lost to desert conditions every 12 months without pause. By 2015, the total area of desertified land in China had ballooned to 2.62 million square kilometers, 1/3 of the entire country, gone or going. The human consequences of this were devastating. Entire farming communities found their fields buried under advancing dunes. Sandstorms, massive choking walls of dust and fine particles, began sweeping across northern China with increasing frequency, reaching as far as Beijing, turning skies orange and grinding daily life to a halt. Millions of rural residents who depended on the land for their livelihoods found themselves watching that land disappear beneath them. There is a phrase in Chinese environmental policy circles that captures the urgency of what was happening: Shamou Hua, the March of the Desert. And in the final decades of the 20th century, the desert was winning. China, to its credit, did not choose denial. The government understood, and stated publicly, that addressing desertification was not simply a domestic obligation. It was a matter of global ecological responsibility. The degradation of soil on this scale doesn't just hurt the communities immediately affected. It contributes to climate instability, reduces the planet's capacity to absorb carbon, and threatens agricultural systems that feed hundreds of millions of people. So China began to act. A series of large-scale national programs were launched to combat the advancing sand. The most famous of these was what became known internationally as the Great Green Wall, a massive afforestation campaign designed to plant a belt of trees across northern China, wide enough and dense enough to slow the movement of desert sands. Billions of trees were planted. Policies restricting overgrazing were introduced. Sand barriers made of straw were laid down in grid patterns to stabilize dunes and give young plants a chance to take root. These efforts were significant, they were necessary, and they helped, but they were not enough on their own. Because here's the thing about fighting desertification. You can plant trees, and if the underlying ecosystem doesn't support them, they will die. You can lay down grass seeds, and if there is no mechanism to enrich the soil and help those seeds germinate, they will blow away in the wind. And you can fence off degraded land and tell people to stay out. But if you don't give those same people a viable economic alternative, they will be forced back in, because they need to eat and they need to survive. Effective desertification control, it turned out, required more than good intentions. It required a completely new way of thinking about how human beings, animals, and ecosystems could work together. And that new way of thinking had a name. In 1988, one of China's most celebrated scientific minds turned his attention to the desert. Qian Shuisun was not an environmental scientist by training. He was a physicist and aerospace engineer, one of the founding figures of China's missile and space programs, a man whose contributions to science and technology had already secured his place in Chinese national history. But in the later years of his career, Chen became deeply interested in systems thinking, the idea that complex problems can only be solved by understanding the full network of relationships and forces at play, rather than by targeting individual symptoms in isolation. When he looked at China's desertification crisis, what he saw disturbed him. The prevailing approach, plant trees, build windbreaks, stabilize sand dunes, was well-intentioned, he acknowledged. But it treated the desert as a problem to be physically blocked rather than an ecosystem to be rebuilt. It focused on suppression rather than regeneration. And critically, it ignored the economic dimension entirely. Qian Shuisun argued, in a series of papers and public statements that would prove remarkably prescient, that the only way to truly and sustainably reverse desertification was to approach the desert as a system. Not just a physical system of soil and wind and water, but an economic and social system as well. His vision was ambitious. He proposed the development of what he called a knowledge-intensive industry for desert regions, one that would organically combine forestry, grassland management, and animal husbandry into a single, mutually reinforcing industrial chain. In his model, the desert would not simply be reclaimed, it would be made productive. It would generate income for the communities living around it. It would give local people a financial stake in the health of the land, so that protecting the ecosystem would also mean protecting their own livelihoods. This was a profound shift in thinking. And it took time for the broader policy establishment to fully catch up. But Qian's ideas did not fall on deaf ears in the business community. Chinese entrepreneurs, always alert to opportunity, especially in places that others had written off, began to look at the desert through a different lens. Where conventional wisdom saw only waste and hardship, they began to see potential. Untapped land, underutilized space, a resource waiting for the right strategy. Motivated by Qian Shuisun's framework, a group of forward-thinking investors began making serious inquiries into desert development. The numbers they were considering were not small. plans emerged to invest up to 750 million yuan, a figure equivalent to hundreds of millions of US dollars, in establishing a large-scale ecological agricultural base in the Inner Mongolian desert. The centerpiece of that base would be a 300,000-acre plantation of salix, a genus of shrub commonly known as willow or saltbush, whose deep roots and hardy structure made it exceptionally well-suited for stabilizing desert sand. The goal was to use this salix base as the foundation for greening an even larger surrounding area, up to 3 million acres of degraded land. It was a bold, expensive, and genuinely visionary plan. But there was still a missing piece. A salix plantation could stabilize sand and provide ground cover. But on its own, it couldn't create the kind of rich, active, living soil that a true ecosystem needs. It couldn't generate the sustained economic returns that would keep investors engaged and give local farmers a reason to participate. For that, the planners needed something else. They needed an animal. The search for the right animal to introduce into the desert ecosystem was careful and methodical. Chinese researchers and entrepreneurs considered multiple species. They looked for animals that could thrive in dry conditions, that would interact positively with the existing and planned vegetation, that could reproduce quickly enough to scale without requiring enormous inputs, and, critically, that had genuine commercial value so that their presence in the desert would benefit not just the ecosystem, but the local economy. After extensive research and consultation, they landed on a somewhat surprising candidate: a rabbit. Not just any rabbit, a specific breed originally developed in France, known in Chinese agricultural circles as the Rex hare, or in Mandarin, Lao Tu. In scientific and agricultural literature, this breed is classified as a large, short-haired rabbit with a distinctive velvety coat that gives it significant value in the fur and textile industry. When the proposal was first floated to introduce French rabbits into a Chinese desert as part of a desertification control strategy, the reaction from many observers was, to put it diplomatically, skeptical. Rabbits, after all, are not typically the animals you think of when you think of ecological restoration. In other parts of the world, Australia being the most famous example, introduced rabbit populations have caused ecological catastrophe, devouring vegetation, destabilizing soil, and driving native species to extinction. Why would putting rabbits in a desert be any different? The answer, it turned out, lay in a very specific combination of factors: the particular characteristics of the Rex hare breed, the particular ecology of the Inner Mongolian desert landscape, and the particular way in which the introduction was managed and controlled. Let's break that down. The Rex hare is not your average domesticated rabbit. Originating from France, it was selectively bred over generations for specific traits: a calm temperament, robust health, rapid growth, and most famously, its dense, short, incredibly soft fur. That fur, which has the texture of fine velvet, has long made it a prized material in the luxury fashion industry, used in the production of high-end coats, trimmings, and accessories. But it's not just the Rex hare's commercial value that made it suitable for desert deployment. It's its biology. Rex hares have evolved strong preferences for dry, clean living environments. Unlike many animals that require access to consistent water sources or humid conditions to remain healthy, these rabbits are remarkably well adapted to arid conditions. The dry, well-ventilated environment of a managed desert enclosure is, in many ways, closer to their preferred habitat than the damp, muddy conditions of many conventional rabbit farms. This made the Inner Mongolian desert not a challenge for the Rex hare, but something close to an ideal home. Now, here is where the ecological story gets genuinely fascinating. Rex hares, when left to behave naturally, spend a significant portion of their time digging. They burrow. They scratch and root around in the earth in search of underground grass roots, dried plant matter, and other buried organic material. Unlike many herbivores, they are not particularly interested in hard seeds with shells. Their digestive systems are not built to process them efficiently. What they can process is soft, fibrous plant material and the roots and underground stems of desert grasses and shrubs. This digging behavior, which might sound destructive on the surface, is actually profoundly beneficial to desert soil. Here's why. Desert soil is typically highly compacted and low in organic matter. When you compact soil, you reduce its ability to absorb water, which is already scarce in a desert environment. You also reduce its aeration, which means that the microbial activity necessary for plant growth is severely limited. In essence, compacted desert soil creates a vicious cycle. The harder the soil, the harder it is for plants to grow. The fewer plants there are, the less organic matter returns to the soil, and the less organic matter in the soil, the more compacted and lifeless it becomes. The Rex hare, through its digging, breaks this cycle. Every time a rabbit burrows and roots through the desert floor, it is essentially performing a form of natural tilling. It loosens compacted soil. It creates channels and air pockets that allow both water and oxygen to penetrate deeper. It brings buried organic matter closer to the surface, where it can decompose and release nutrients. And it creates microenvironments, small depressions and disturbed patches of earth, where wind-blown seeds can lodge and germinate rather than simply blowing past. But the rabbit's contribution doesn't stop at their paws. Their droppings, produced in large quantities given the animal's active metabolisms, are extraordinarily rich in nitrogen and phosphorus, the two nutrients most commonly depleted in desert soils and most essential for plant growth. In a functioning ecosystem, this waste would be broken down by insects, bacteria, and fungi into forms that plants can directly absorb. In a degraded desert where that microbial ecosystem has been damaged or destroyed, the introduction of large quantities of rabbit manure can essentially jumpstart the biological processes that make soil fertile. And there is one more piece of the puzzle, perhaps the most elegant one. Because Rex hares cannot fully digest the hard-shelled seeds they occasionally ingest, those seeds pass through their digestive systems intact. When the rabbits deposit their waste across the desert floor, they are essentially acting as seed dispersers, spreading the seeds of native desert plants far and wide, each one wrapped in a small package of nutrient-rich fertilizer. The result? In the managed desert enclosures in Inner Mongolia where Rex hares were introduced, the plant survival rate, the percentage of planted or naturally seeded vegetation that successfully takes root and grows to maturity, reached an astonishing figure of 96% or higher. To put that in context, in conventional desert revegetation efforts, without the support of an active animal ecosystem, plant survival rates are often well below 50%. The difference between those two numbers represents an almost unimaginable improvement in the efficiency and effectiveness of ecological restoration. The desert, it turned out, was not just tolerating the Rex hare, it was being healed by it. One of the reasons the Rex hare was chosen over other potential species was its reproductive rate. And the numbers here are frankly remarkable. A single female Rex hare can produce approximately 40 offspring per year. When you factor in that those offspring themselves reach reproductive maturity relatively quickly, the compounding effect is extraordinary. Researchers and agricultural planners noted that the Rex hare's reproduction rate was roughly 25 times higher than that of many conventional livestock animals raised for similar purposes. What this means in practice is that a desert rabbit program can scale faster than almost any other livestock-based ecological intervention on record. China launched its desert rabbit program in the Dalad Banner region and watched it grow with remarkable speed. From a small initial cohort of carefully monitored animals, the population expanded steadily under controlled management. Breeding facilities were established. Feeding and water infrastructure was put in place. Veterinary and monitoring systems were developed to keep the population healthy and the ecological impact positive. By the time the program had reached maturity, more than 1.2 million Rex hares had been raised across the desert landscape. 1.2 million rabbits moving through the sand, digging, eating, fertilizing, seed spreading, day after day, season after season. The ecological impact was not subtle. Areas that had been bare sand began to show vegetation. Patches of green appeared where nothing had grown in years. The salix plantations that formed the backbone of the revegetation effort began to thrive in a way they hadn't before, because the soil around them was being actively enriched and aerated by the rabbit population living among them. And as the vegetation grew denser and more established, it began to do what healthy vegetation always does in a desert environment. It stabilized the sand. It reduced wind erosion. It created shade and ground-level humidity that allowed even more plant species to take hold. The Oasis effect, the phenomenon by which a small patch of established vegetation creates conditions favorable enough for further growth, gradually expanding outward, began to take hold. A feedback loop had been created, and for once it was running in the right direction. No account of China's desert rabbit program would be complete without discussing the plant that made it all possible. Salix, the genus of hardy, deep-rooting shrubs planted across millions of acres of the Inner Mongolian desert, was not chosen at random. These plants have evolved over millions of years to survive in the precise conditions that define degraded desert landscapes: thin, nutrient-poor soil, extreme temperature variations, low and unpredictable rainfall, and the constant mechanical stress of windblown sand. Their root systems are deep and extensive, allowing them to access underground water and anchor themselves against the forces that would otherwise pull them free. In the context of desertification control, salix serves two critical functions. First, it physically stabilizes sand. Its roots and above-ground structure act as a barrier against wind erosion, slowing the movement of dunes and giving other plants a chance to establish themselves in the more sheltered conditions created in its wake. Second, it begins the long process of improving soil quality by adding organic matter as its leaves fall and decompose. But salix also plays a direct role in the rabbit program. For the Rex hare, the leaves, shoots, and softer stems of salix plants represent a high-quality, readily available food source perfectly suited to their digestive systems. In an environment where other food sources are scarce, the salix plantations provide the nutritional foundation that keeps the rabbit population healthy and productive. In turn, the rabbits fertilize and aerate the soil around the salix plants, helping them grow more vigorously. The rabbits also disperse seeds, including, in some cases, the seeds of the salix itself, further expanding the plantation's reach. This is what ecologists call a mutualistic relationship, a partnership in which both species benefit from the presence and activities of the other. And in the context of the broader desert reclamation project, this mutualism became the engine that drove everything else. The Chinese planners had effectively created a miniature working ecosystem where each component, the desert soil, the salix plants, and the Rex hare population, reinforced and supported the others. It was precisely the kind of integrated, systems-based approach that Chen Shixin had envisioned more than 2 decades earlier. Theory, at long last, had become reality. It is one thing to restore an ecosystem. It is another thing entirely to make that restoration economically sustainable in the long term. China's desert rabbit program succeeded not just because it worked ecologically, but because it worked financially. And understanding that financial dimension is essential to understanding why this model has attracted such attention from governments, development organizations, and environmental planners around the world. Let's start with the most obvious economic asset, the rabbits themselves. Rex hares are commercially valuable animals in 2 distinct ways. The first is as a food source. Rabbit meat is lean, high in protein, low in fat, and widely consumed across China and many other parts of the world. The large-scale breeding operation in the Inner Mongolian desert produces a significant and steady supply of rabbit meat that can be processed and sold through established food distribution networks. The second, and arguably more economically significant source of value, is the Rex hare's fur. The dense, velvety coat that gives this breed its name is among the softest and most commercially desirable rabbit furs in the world. In the global luxury fashion industry, Rex hare fur commands premium prices and is used in the production of high-end outerwear, trimmings, and accessories. China, already the world's largest producer and exporter of rabbit fur products, has been able to channel the output of the desert breeding program directly into established international supply chains. For local farmers and herders living in and around the Dalad Banner region, communities that had historically struggled with poverty and economic instability, partly as a direct consequence of desertification destroying their agricultural land, the Rex Hare program represented a transformational economic opportunity. The numbers tell the story clearly. As the program scaled and matured, the average annual income of farmers participating in the desert rabbit breeding operation rose to approximately $20,000. In a region where poverty had been persistent and deep-rooted, this was not a marginal improvement. It was a generational change, the kind of income increase that allows families to invest in education, healthcare, and housing in ways that break cycles of poverty rather than simply managing them. And the economic benefits did not stop at the farm gate. The Desert Rabbit program became the seed, if you'll forgive the metaphor, of a much broader and more diversified local economy. Processing facilities for rabbit meat and fur created employment in rural towns that had previously offered very limited job opportunities. Transportation and logistics networks developed to move products from the